Hi everybody. Today I'll be talking about estimating surface porosities of analog samples using microscopic imaging analysis. And this is brought to you by myself, Ryan Galinkin, and my advisor, Dr. Carrie Donaldson-Hanna. So a quick background here. On the lunar surface, the lack of an atmosphere and low surface gravity results in delicate structures of stacked surface particles, resulting in a very high porosity compared to terrestrial standards. This high porosity modifies the thermal infrared spectra observed by orbiting spacecraft and in situ instruments. Thus, it's imperative to properly characterize these surface particle structures. Several laboratory studies have created samples with a range of porosities. These porosities are normally given relative to each other. However, attempting to accurately quantify these porosities in a laboratory study has yet to have been attempted. So, we're going to go over our methods in sample production. So in this study, we prepared 3 different observable porosities. A low porosity, which we compressed under a 20 kilogram mass. A medium porosity, poured and then leveled with a straight edge. And then finally, a high porosity, poured into a sieve and gently shaken above a sample cup. After we had these samples, we used an imaging microscope and we take an image at the center of each of these samples under 20 times magnification. We then generated masks within ENVI to cover the dark pixels. The dark pixels are those that we considered to be voids rather than particles. And pixels darker than this threshold are forced to black, and those lighter are forced to white. This process was reproduced after rotating the sample cup 10 times under the microscope. We then averaged the number of resulting dark pixels. So that brings us to our results. More porous samples result in masks covering more dark pixels. That's exactly what we were looking for. This means that our image processing technique correctly estimates the porosity of the samples. So in our middle image here, we have the green band images, and at the top we have the most porous, which was the SEVD. Then we come down to the leveled, and then we come to the most packed sample, the least porous, which was the packed. To the right of these images, we have our corresponding masks. And as you can see, it correctly ranked them by the porosity, with the highest porosity being designated to the SEVD and the lowest being to the packed. For the SEVD sample, we're getting a porosity of about 50%, and the leveled sample, we're getting about 28%, and lastly, the packed sample, we're getting something around 10%. If you'd like to know more about this, please feel free to tune in to poster session 1. My poster ID is NESF 2020-037. Also, feel free to email me at ryan.galinkin@knights.ucf.edu. Thanks for joining me.